Okay, so this is a derivative review from basics, not the product quotient, chain rule, all before that. Just the power rule, the constant rule, a bunch of questions just on that. We're going to start with the first one here. We're asked to find the derivative where y is equal to x to the 12. And so what we're doing is the power rule. And the power rule goes like this. If x is raised to a number, then your derivative is that number times x to 1 less. So over here, dy dx is equal to 12 times x to the 11. Okay. Next to number 2, if you have a constant whose times a function, when you want to go take the derivative of that, what you do is you bring the constant down and you focus on the derivative of the actual function. So if I want to take the derivative of y equals 2x to the 0.45, then I copy down the 2 and I focus on the x to the 0.45, and I'm going to use the power rule on that. 0.45 times x to the 0.45 take away 1, 45 cents, take away $1, you're 55 cents in the hole. So negative 0.55. And what you can do with that is multiply here, and that'll be 0.9 x to the negative 0.55. Okay, great. On the third one over here, we have multiple terms. So the new rule here is that the derivative, if your function is the sum of two functions, then your derivative would be the sum of the derivatives. You take f prime of x and add on g prime of x. So first term has a 3 in front. So the derivative is going to have that same 3 in front. Bring down this 5, take x to the 4. That's not 35. That's 3 times 5. That's going to be 15, x to the 4th. Okay, here's our first experience with a negative exponent. But so what? It'll be negative 3 times x to the take away 1. What is negative 3 take away 1? It's going to be negative 4. Now this plus or minus, you could do what you want with it. I'm going to call it a minus. And then the last term is negative 5. And so 5 is being subtracted from all that. And so we have rule number 1 here, the power rule. Second rule we talked about here is the constant rule. Here is the sum rule. And here's another one. If your function is a constant, then the derivative of that is 0. The slope of a tangent line to a horizontal function is the fact that you'll have a 0 slope. The function is horizontal. There is no slope there. So plus nothing, and you don't need to keep that there. You can drop it. All right, now our first experience with the radical symbol. Radical x is x raised to the 1/2 power. Radical symbols are going to do you no good when it's time to take the derivative. You need the fractional exponent version. And so if you're looking at 8 rad x, then you change it to be 8x to the 1/2, so that when it's time to take the derivative, you can use the power rule. Remember constants, you just carry them down. Don't do anything with the constant. Focus on the part that is the function. Bring down the exponent and take away 1 from it. If you're at 1/2 and you take away 1, you're at negative 1/2. And what you do with those constants is, like we did before, you multiply them together. So it's 4x to the negative 1/2. Okay, great. All right. Now we have to do some things before we can use the power rule and the sum rule and the difference rule. With number 5 here, we're going to have to FOIL this out. So your function is 2x cubed plus 3x squared minus 16x minus 24. So it's time to take the derivative, keep the constant, focus on the x part, bring down the 3, take x to the 2. That's a 6x squared. Bring down the 3, keep this 3, carry this 3 down. Focus on the x squared part, bring down the 2, take x to the 1. Multiply those together and just call it 6x. You don't need to put a 1 on there. Bring down the minus 16. Now it's x to the 1. So what that's going to be is 1 times x to the 0, but x to the 0 is going to be 1. And so if we ever have a function who is m times x, your derivative is just going to be m. And so that's just going to be minus 16. And then this guy's derivative is 0. So there's the derivative of that function. Okay, great. Here we are with another situation where we have to do something to get us into exponents that we can use it for the power rule. And so if you have the fourth root of something, that's something raised to the 1/4 power. If you have some constant who's over the variable, you're going to bring that variable up to be a -1. Or if it's squared, we'll bring it up as a -2. And so keep the constant. So that's what we're going to do here. Rewrite y first. Do an algebra step. Call it t to the 1/4 minus, this would be t to the -1. No need to say 1 times that. Just leave it like as t to the -1 instead of 1 times t to the -1. So this is the rewrite of the function. And now after this rewrite, we can now take the derivative using the symbol that they want us to use here, dy dt. Bring down the 1/4 and take t to the 1/4. Take away 1. That's -3/4. Now this minus sign is in between. It's the same as the sum rule. And what we're going to do is bring down the -1 and take t to the -2. So just to fix up this answer, we'll have 1/4 t to the -3/4 and then plus t to the -2. Okay. The derivative for number 7 is going to be carry down the -3.5. Don't do anything with that. This -2 exponent comes down, and then you take away 1 from that. That gives you -3 exponent. 6.5, that's a constant. So that's nothing for the derivative. And when we put these together, if you double 3.5, you get 7. Negative and negative is a positive. So that's going to be 7x to the -3. Okay. Now we already have the fractional exponents in number 8. So when it's time to write the derivative, keep the constant 3, bring down the 2/3. 2/3 take away 1 is a -1/3. The minus sign between the two functions gets carried down. You bring down the -1/3 for the exponent. Don't forget though, you got to take x to the -1/3. Take away 1 is -4/3. Simplify. So your derivative it's going to be, cancel those 3's, 2x to the negative 1/3, and let's go ahead and call this plus 1/3 x to the negative 4/3. Okay, great. Let's chop this into 2 videos. Let's go ahead and stop here.